In this class, we will discuss some important complexes of chapter of coordination compound class 12th for IIT JEE. These are some exceptional cases, or you can say these are very important coordination compound or complexes. When we apply the VBT valence bond theory on these complexes, then we have to remember that your first complex that is important, CONO2 6 4. Now you can see the oxidation state of cobalt in this complex is +2. So obviously its electronic configuration will be 3d7. Actually magnetic moment indicate the complex ion have paramagnetic character, means there is presence of unpaired electron. One unpaired electron is present. That is proved by magnetic moment measurements. Now actually NO2 minus is a strong ligand, so it can cause the pairing of 3d electrons. Now what happen in its 3d 7 configuration, there are actually 2 plus 2 and these are 3, so total 7 electrons are present in d orbital. So what happen, these two electrons paired up, only these two electrons paired up, and this electron will migrate towards 5s orbital. So this electron will migrate in 5s orbital. So only two electrons will be paired up in the presence of NO2 minus ligand. So one unpaired electron is present in 5s orbital. That's why it is a paramagnetic. The presence of this unpaired electron in 5s orbital is also supported by the fact that 5s orbital has high energy because of presence of unpaired electron, and the electron present in it is loosely bonded, so it can remove very easily. So when we oxidize this complex by air or H2O2, it can easily convert into CONO2 6 minus 3, means CO plus 2 ion gets converted into CO plus 3, cobalt plus 3 state, means it can give easily electron. So it is actually unstable in air. So that's why this complex should be prepared in inert atmosphere. So this complex is very important because one unpaired electron is present in 5s orbital. Another important complex is Mn6 minus 3 ion. In this complex, we can say Mn is in +3 oxidation state. That's why its electronic configuration is 3d4. Now magnetic measurements show the complex is paramagnetic. It have actually Cn6. So Cn is actually a strong ligand. So it should paired up the electron. But what happen in its +3 state or 3d4? In 3d4 electronic configuration, 4 electrons are present in D. Now what happen? Only two electrons are paired up. Only two electrons are paired up, and the other two electrons does not paired up. They remain unpaired, because if they also paired up, then it will violate the Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity tell us that the orbitals in degenerate orbitals, when we fill the electrons, then first of all electrons should be filled unpaired. So two electrons are unpaired, then only two electrons will be paired up. So due to these unpaired electrons, actually it have paramagnetic character. The another important example is Cr Cn6 3. In this complex, Cr is +3 state. So its configuration is 3d3. So what happen? It have Cn ligand is a strong ligand, and we can say that it is diamagnetic. But actually what happened, magnetic measurement, practically magnetic measurement show that this is also paramagnetic. So means there are three unpaired electron are present. Now actually what happened, there are three unpaired electrons. Now what happened, these three unpaired electrons remain unpaired, and two d orbitals are empty. So again hybridization is okay. Hybridization is d2sp3, geometrical shape is octahedral, and it is inner orbital complex, but in this complex also three unpaired electron are present in d orbital, because same, if we do the pairing of electron, then it will violate the Hund's rule of maximum multiplicity. So always remember, when you are pairing the electron, you should consider the Hund's rule of maximum multiplicity. Then VNS36 plus 3 ion. In this case, vanadium is plus 3 oxidation state. NS3 is a strong ligand, but magnetic measurement also show that it is a paramagnetic characteristic. So its configuration is 3d2. 3d2 means two electrons are present in d orbital and these two electrons remain unpaired. So two d orbitals are empty, so they take participate in hybridization, and d2sp3 hybridization, octahedral geometrical shape, inner orbital complex, that all are correct. But here also we should not pair up the electrons, because if we paired up the electron it would violate the Hund's rule of maximum multiplicity. So again two unpaired electrons are present in this complex. So these are actually very important complexes in which we should remember that when we have to pair up the electrons or when we have not paired up the electron. In our first compound CuNO2 6 minus 4. Yes, hybridization is D2sp3 octahedral geometry inner orbital complex, but one unpaired electron is present. In another example MnCN6 minus 3. Again, the hybridization is G2sp3 octahedral geometrical shape inner orbital complex is formed, but unpaired electron is also present. In another example CrCN6 minus 3, then this is also D2sp3 hybridization inner orbital complex octahedral geometrical, but unpaired electrons are present. Means we should consider the pairing should be according to Hund's rule of maximum multiplicity. We should do the pairing in such a way that it should not violate the Hund's rule of maximum multiplicity. Thank you.